What if everything you know is wrong?
You know, when you think about climate change, what's the first thing that comes to mind? For most of us, it's heat, right? Rising temperatures, melting ice caps. But the real story, the one the planet is screaming at us, and that the latest science from the IPCC confirms, is that the climate crisis is, at its very core, a water crisis. So, let's break down what that actually means.
I want to start with just one number, a really, really big one, 4 billion. That's what that number represents, 4 billion people. Half of all of us on this planet are already dealing with a serious lack of water for at least a month every single year. This isn't some far-off future problem. Nope. This is the reality for billions of people right now, and it's a massive threat to our water security.
And when we say water security, we're not just talking about having a glass of water when you're thirsty. It's so much bigger than that. It's about having enough clean, reliable water to grow our food, to run our economies, to stay healthy, and to keep our ecosystems alive. It's literally the foundation of a stable society.
So how exactly is climate change fueling this crisis? Well, the main engine behind all this is something scientists call the intensification of the water cycle. A simpler way to think about it, we've basically supercharged the planet's entire plumbing system.
The science on this is absolutely solid. As the IPCC report states, a warmer atmosphere acts like a giant, thirsty sponge. It holds moisture. For every single degree of warming, it can hold about 7% more water vapor. And that doesn't just mean a little more rain. It means the entire system gets more extreme, more volatile.
And this gets to this kind of wild paradox of climate change. A supercharged water cycle means that when it finally does rain, it really, really pours. We get these incredibly intense downpours that cause massive flooding. But at the same time, all that extra heat is also sucking moisture out of the ground faster, leading to longer, harsher droughts. So we end up with both extremes, wetter wets and much, much drier dries.
And this isn't just a theory. We're seeing it in the real world. Think about this. Roughly 709 million people are now living in places where the single heaviest day of rain all year has gotten way more intense since the 1950s. But believe it or not, that's only half the story.
Because at the exact same time, another 700 million people are living with the total opposite problem. Their dry spells are getting longer and happening more often. It's a world of extremes, and hundreds of millions of people are caught on both sides of this coin.
Okay, so let's zoom in a bit on what this actually looks like on the ground. Let's talk about the real-world impacts of these devastating floods and crippling droughts.
Now, this is fascinating. What you're seeing here tells a really powerful story. From 1970 to 2019, floods made up almost half of all disaster events. They're common, they're dramatic, we see them on the news all the time. But now look at droughts. They accounted for just 7% of events, but were responsible for a staggering 34% of all disaster-related deaths. The takeaway here is huge. Droughts are quiet, slow-moving disasters, but they are incredibly deadly. And the impacts just keep cascading outwards. We're losing our planet's glaciers at a terrifying rate, which threatens the water supply for over 1 billion people. Droughts are absolutely hammering our farms, costing hundreds of billions of dollars. Even our energy grids are at risk, with power output dropping during dry years. It touches everything. So that brings us to the future. And what the science makes clear is that our future isn't set in stone. It's more like a set of different paths, in which when we go down depends entirely on how much warmer we let the planet get. And the relationship here could not be more direct. Every fraction of a degree of warming just dials up the risk. It increases the volatility, it amplifies the extremes, and it makes the consequences worse for every single one of us. Let's put that in perspective. What does this mean for our food supply? Well, at 1.5 degrees of warming, those really extreme droughts, the kind that wipe out harvests, are expected to be twice as likely. Okay, not great, but at 2 degrees, they become up to 3 times more likely. And if we were to hit 4 degrees, well, the risk just goes through the roof. Now let's flip over to the other extreme, flooding. At 2 degrees of warming, the number of people at risk from major river floods could jump by 120% compared to a 1.5-degree world. But look what happens at 4 degrees, a 400% increase. You see how this isn't a straight line? The danger ramps up incredibly fast. And we have to remember, behind all these charts and percentages are people's homes, their farms, their safety. These risks don't fall equally. They hit the most vulnerable communities the hardest, the ones who have the fewest resources to deal with the fallout.
So, what can we do about all this? This is where the idea of adaptation comes in. These are the actions we take to manage the risks we know we can't avoid.
And this chart really shows you just how central water is to our response. Right now, a huge majority, 60% of all the climate adaptation efforts happening around the world are focused on dealing with water. We're talking about things like smarter irrigation, harvesting rainwater, and protecting wetlands. And this is a really, really critical point. Adaptation is not a magic wand. It's not a get-out-of-jail-free card that will work no matter how bad things get. There are hard limits to what we can adapt to.
And here are the stakes, laid out by the IPCC itself. The hotter it gets, the less our adaptation strategies actually work. It's that simple. Once we go past 1.5 degrees, some places will hit biophysical limits, meaning no amount of clever engineering can bring back a melted glacier or replace a dried-up river.
All of this leaves us standing at a critical crossroads. The choices we make about emissions right now, in the next few years, will literally decide what the future of water looks like for generations.
And this is where it gets really tricky. It's a tough balancing act. On one hand, we know that having enough water is essential for pretty much every global goal we have, from ending poverty to good health. But on the other hand, many of our big ideas for fighting climate change, like planting massive forests or growing crops for bioenergy, need a ton of water themselves. We can't solve one problem by making the other one worse. We have to be smart and find solutions that help both.
Ultimately, the science leaves no room for doubt. Our climate future is our water future. They're the same story. The data shows us the different paths we can take, one with manageable risks and others with escalating, maybe even impossible challenges. The only question left is, which path are we going to choose?
Understanding begins with why.